Welcome. Shout out to my study group. Appreciate you all for coming through today for this particular session. I'm Zaddle. Welcome to Packet Chasers. Appreciate you all for coming through today. Today we're going to be configuring a static route on live Cisco routers. Now, the question is, what good is a static route? Well, you may be in a situation where you need to get a particular group subnet routed through your network and you need to do it quick. So sometimes you got to do a static route. I'm not to hear the reason, I'm here to show you the way. Switch one. So meanwhile, while that's all going on, let me go over IP address range we're going to be using, which 28. That means it's 4 bits for the host. Let me see. Host, nets, host. Right, so we're going to have in a stroke 28, 255.255.255, that's 24 plus 1, 2, 3, 4. So it's going to be 28 mask bits. So that's going to leave 4 bits, 1, 2, 3, 4 for the subnet mask. So in order for us to figure out what the subnet mask is for this, we're going to take the first 4 bits that are masked, add them together. So that's 128 plus 64 plus 32 plus 16. Let me get out the calculator for that one, folks. I should know that by heart, but I'm going to get out the calculator for it. Right, so we're talking about 128 plus 64 plus 32 plus 16, 240. So that's going to be a .240 subnet mask. 240, and then we got 4 bits that's going to be used for the host range, right? So those bits that are going to be used for the host range is 2 to the n minus 2, where that's 2 times 2 times 2 times 2, right? So let me strike that out. That's going to be, let me see, 1 plus, 1 plus 2 plus 4 plus 8. So that's going to be 8, 12, 13, 14, 15 plus 1. That's going to equal 16. Right, so it's going to be 16 hosts per net. right? And then 192.168.1, right? We know that's gonna start the range off. And it's gonna be dot 1 through dot 16, right? So the next range will be, I'm just gonna put them right here, 30, my bad, 32 plus 16, 32 plus 16 is 48, plus 16, 64, plus 16 is 80, plus 16 is 96. And so this next range is the range we gonna live in. 96 plus 16 is 112. So 112. So this is the IP. We got 97 through 100 to use. So that's going to be this range right here, 97 through 112 with a 192.168.1 first three octets, .97 with a mask of 240 with a 240 subnet mask. I think I hit the slash the wrong way. Let me see. Nah, stroke 240. Right? So there it is there. I mean, stroke 28, stroke 28. I'm going to replace that with the, so we know what we're working with. Right? I didn't count up the number of nets that equaled up to, so I'm going to have to review the video. But it was like, here, we could just take 256 and divide that by 16. That's going to give us 16 nets with 16 hosts. Here we go right there. Right? So now that part of the business is over, on to task 2. All right, so we complete with task 1. We was able to figure out that what the IP address range is that we can use, and it was like 97 through 112, I think. 97 through 112. So those are the IP addresses that our PCs can use, so that's cool. That's going to be fine. All right, our next task is going to be to assign these two IP addresses to router 1 in the terminal server, which that's our second router we're using today for this lab, which is the terminal server and the router 1. They're connected by a serial cable. Let me see, R1. All right, so here we go. I got the IP addresses of the different switches, switch 1, switch 2, switch 3, 29, 28, as we said. they not pingable. 192.168.1.29. It's not pingable from router 1. Oh, it is pingable. Control Shift 6X. Alright, let me see. Ping 192.168.1.29. Alright, so we can't ping that from the terminal server. 28. Alright, so the terminal server doesn't have any routes to 192.168 network. Show IP route. Alright, cool. So now we're gonna, once we create this point-to-point network, the terminal server should now have routes to these devices. Hold up, it should be able to ping 1.30, 192.168.1.30. Alright, that's the 1.30 is router R1. And so this is R1. Right, so why don't we do this? Let's go to R1 and wait, we on the terminal server first, so we're going to skip the task 3. We're going to configure an IP address on that serial interface right here on this S000, which connects to R1. So let me see, config T int S 0/0/0 IP address. Right, let me see, it's going to be task 3. It's going to be 10.1.1.2 with a 222.550. Right, no shut. Do show run int S0/0/0. Right, so there it is. That serial interface is configured. Control Z, right, show int S0/0/0. Alright, so it's up, right? Alright, so next we want to do is go to R1, show sessions. R1 is on 3. So on R1, we're going to go to task 2, which is assign an IP address to that serial face that's connecting to the terminal server, which is, there it is, S010. Here, let me do a show IP route in R1. As you can see, R1 has routes to that 192.168 network. Right, so here we go. Config T int S 0/, hold up, 0/0/0. Oh, all right. It's 010 then. 01001 stroke 0 IP add. Right. So this is going to be R1. So it's going to be 10.1.1.1 with a 222550. Right. No shut. Do show run int s 0 stroke 1 stroke 0. Right. You can see that's the side with the clock rate. Control Z. Right. All right. So from R1, we should be able to ping the terminal server address. Right. Ping 10.1.1.2. Right, so from R1 we can ping the terminal server. Now that was task 4, pinging the interfaces. Task 5, we're gonna add this static route to the terminal server so that we can start getting some pinging on that 192 net, or we get routes to the 192 net on that terminal server. Control Shift 6X, show IP route. All right, now it does have a route directly connected to it. Let me see if these pings will work. 1.30, that should work. 1.30 is R1. 1.29. 1.28. Boom. All right. So that's IP subnetting that's allowing those to connect. So right now, I'm going to route all the 192.168 out of, let me see, from to S010 from this terminal server. So here. So this is a static route here. My bad. 0 stroke 0. Boom. Control Z. Show run. Yeah, that's the right one. We could also route it via IP address. Like IP route IP route. All right, so here, let's look on the router and see the command. There it is right there, IP route. This is for a different lab. I'm gonna get rid of this right here. Alright, so there's the static route right there, IP route, all of that 192.168.1.0. Route that out of serial 00000. We could look at the picture. Like right now, we're on the terminal server, and we're telling the device to any data or any packets that's destined for 192.168.1.29 routed through S000. Now, this trunk link from the terminal server to S1, that's the reason why we seeing that 192 net directly connected. If that link wasn't there, it wouldn't have a direct connection, and the only way it could get packets to this S1 is through this R1, right? So let's take a look at the show IP route, right? Again, we're going to see that 192 is directly connected to that through that serial 000 interface. Show CDP neighbor, right? R1 is directly connected on serial 010 to serial 000 on the terminal server, right? Let's go back to R1. R1, which is on 3. All right, we see that 192 network is directly connected on FE00 and on loopback 1, right? So let me see. So this one is on 010, right? So I'm going to route it back. I'm going to send another static route back to the other direction for the sake of the lab, just so we can see how it's going to react. Here, let me see. Control Z, 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 Z. It's going to be 010. Right, let me save that little housekeeping here. RMTS 0/1/0. No, that's a global command. Apologies. Control C. Control Z. Show run. No. Show. Alright, so here we see it now connected on that serial interface S10. We could also configure so it'll route through that IP address also. So let me do that real quick. Show run. See what this is the IP address on there. Control C. IP route. IP route through that 10.1.111 interface, right? So we can also issue this command so that you can either route this through the interface, or you can route it through the IP schema. It's best to route it through the IP schema because it's less overhead. Oh, next hop is 2. Oops, my bad. Next hop is 2, right? So there we go. 2, which 2 is the IP address of the other side of this serial link, which is that terminal server, right? Show IP route. There it is right there. See, we're going to get some statistics on it and everything when you route it through the IP address rather than routing it through the interface through 10.1.1.2, right? So task 5, we were able to ping through all the devices. What we could do now is, let me see, terminal server. Let me see here, Control Shift 6X, show IP, show ARP. 1.81. All right, I just needed to look at something real quick. It's that terminal server show IP route. As you can see, like this one that doesn't have an IP address, we don't get any additional metrics on the value of the link. All right, chat. So for a little added additional info, I was gonna disconnect this FE01 right here. This is what's connected to switch 1. Int FA01 shut show IP int brief. All right, so that's down now, right? And so we're on the terminal server, and so Control Shift 6X show IP route. So the 192 is the only way you can get there now is through that serial interface, right? We're going to reattempt these ping commands real quick. Ping 192.168.1.switch 129, right? So it's successful. So I'm gonna take that static route away. Show run. I'm gonna remove those static route. IP route. We're gonna remove this right here. Control C. Config T. No. Right, and then Control Z. Oh, let me see. Control Shift 6X. Show run. All right. Show IP route. All right, so it's no route to the 192 net now that we took out that static route. Now we're going to try to ping 1.29 again. It's unpingable. Now we're going to add that static route back. Save that because I'm gonna need to build up on other labs. Control Shift 6X, show IP route. All right, so now we have a route in there for that 192 net, right? So now we should be able to ping that 129 successfully, right? So now let me bring up let me do some lab cleanup real quick. Bring this interface back up. All right, so that interface is up, or up. There it is, right? No, it's up, down. All right, I gotta see why it's up, down. Probably will come up in a minute. Change state to down. Show IP int brief. All right, now it's up, FE. No. Oh, I'm on router 1. Control Shift 6 X. Show IP int brief. 01 is up, down. All right, I'll figure that out on another day. Anyway, I'd like to thank you all for stopping by today. Please let me know if there's anything else we can do to improve this lab session. If you have any questions or complaints, please put them in the comments section. Thanks for coming through. See you at the next video.